be also the smallest number. And you'll probably find that that's quite hard. But now if I give you a little aid and I give you a visual cue, for example, a color, then you'll probably see that now it's actually quite easy to find the largest number, which is over here, or the smallest number down in the bottom right corner. So by adding just this visual cue, in this case the color, we are just able to process the information a lot faster, and we get the information we want a lot easier and a lot quicker. And that is why we visualize and why we create visualizations. Okay, now as I said, making any old visualization is not that hard, but how do we get to the good visualizations? So I want to give you 3 rules, which we call the 3 golden rules of visualization, that kind of boil down everything you need to think about when you want to create great visualizations. The first rule is send a clear message. Now, when you create a visualization, then usually you do that with a purpose, right? So either you have just an interesting question that you want answered, or maybe you have a problem within your company that you want solved. And so when you create the visualization, it should really be tailored to convey that one clear message. So everything you do to create a visualization, so all the decisions you make, all the design decisions you take, should all be tailored to this one clear message. The second rule is know your audience. Because again, you make a visualization, but it's usually not just for yourself. It's usually something you want to share with others and something you expect others to get information from. So then you first have to know who is the audience. So is it like a general audience, or are those maybe my colleagues who have some specific knowledge they can already access? And then also remember what I said earlier about the data reader. So we also should take into account what is the data literacy level of the people who will later consume our visualizations. So are they used to working with data, or maybe do they need a little bit more help in understanding what they are seeing? And then the third rule is less is more. And I'm sure you've heard variations of that before. And what that just means is whenever we create a visualization, we want to avoid anything that distracts from our clear message. And it also means we don't want to overcomplicate things. So we don't want to add a lot of color, a lot of elements, and a lot of information that we don't need. We make it as simple as possible to get straight to our message. Well, now I will argue that if you really stick to those 3 rules and you always keep them in mind when working on visualizations, then you'll have no problem at all and you'll make really great visualizations. So we could stop here, but I will go into a bit more detail. And for that, let's really look at the basics of visualizations again. So really on a fundamental level, what is it that we do when we visualize? So basically what it means is we have some data, so basically some raw numbers. And what we then do is we translate that into visuals. So that is what we as the data writer do. Translating data into something we can process visually. And then on the backside of that, we also have, of course, our data reader, who then will come and look at the visuals. And the data reader will have to translate that back into raw numbers, back into the data to get the information that the data reader wants to get from the visualization. Okay, now how can we do this? How can we translate the data into visuals? There are actually several graphical elements we can use to encode our information. So for example, we could say we store our data information in the length of our objects. So that would mean the longer the object, the larger the value. We could use any of these others. For example, we could also use the area. So that would mean the larger in size an object, the larger the value. Now there are even more than those 6, but I would say those 6 graphical elements are the basic basic information elements that we have that are used in most of the visualizations we see. And I'm sure all of you have used that, whether you were actually aware of it or not. And an important thing to know about it is that those visual cues are not equal. Because like I said, if you create a visual and then your data reader comes and has to translate that back into a number. And as scientists found out, it's just that people are not, or these kind of visual cues are not equally suited to be translated back into numbers. So if you tell someone to compare lengths with each other and estimate a length, then that will work pretty well. But if we move down this list, for example, and go to the area, if you ask people to compare different areas and translate that back into a number, then it will probably not work as well. And people are just prone to error in this case. Right. Now, this sounds kind of theoretical. So why does this help us? Or why should we be interested in this? Well, I'll argue that really understanding these visual cues helps us to create good visualizations. For once, understanding the visual cues helps us to avoid some common pitfalls. So for that, let's look at this bar chart over here, which shows the sales over the 4 years. So when we think about where the information is stored in this case, we find that the information is encoded in the length of the bar. Right, so the longer the bar, the larger the sales will be in this case. And also, if the bar is twice as long, then the sales will be twice as high. Knowing that, it is quite obvious why something like this is a problem. And I'm sure we've all seen that. So those are actually, this is the same data. But if you look at it closely, you'll find that the axis has been truncated. Right, so the axis doesn't go down until the 0 line. And as a result of that, the problem now is that the information is no longer stored in a length. Because now we see, for example, that this bar is almost twice the length as this bar, but the value is not twice as high. So now there's basically a conflict between where the information is actually stored and where we might expect it to be stored. And that is a problem because it's confusing. So that automatically leads us to the rule we should never truncate the axis in a bar chart. And it also plays into our rule, our golden rule number 1, which is send a clear message. Because if how we encode our information and where the information is actually stored, if that doesn't fit together, then we'll confuse people and we will not send a clear message. We'll send a confusing message. And then those visual cues also help us to make better visualizations in general. And for that, let's look at this example over here, which shows the monthly sales in this kind of bubble chart. Now, if you first look at that, you might be like this person over here and be like, this actually looks quite fun. And I would agree. I mean, I like the bubbles. They look kind of interesting and fun. It's a little bit, it's maybe something different. So yeah, this is fun. However, you might also have this guy over here, and he's a numbers guy, right? He's interested in the details. He wants to crunch the numbers. So he might, for example, see that obviously sales increased from August to September, but by how much? And if I would ask you that, and let all give like a random guess, we'll probably get pretty random answers, so pretty different answers to that. Now, why is that? Well, the information in this case is stored in the size of the bubbles, right? The larger the bubble, the higher the sales value. So the visual cue that we use is the area. And as I've told you earlier, area is just one of those visual cues that we are not particularly good at putting numbers to. So we can improve this chart by changing the way we encode the information. So for example, going back to a bar chart, then this guy will be a lot happier because now he can easily tell, all right, September sales were almost twice as high as August sales. And then maybe this lady down there, she might not find this as fun, but I hope that she at least find it insightful. She'll get some interesting and useful information from that. Now here I'd like to remind you of our rule number 2, which is know your audience, because I don't want to say you're never allowed to use like something like a bubble chart. It's just you should be aware of what the level of detail is that your data readers will be interested in. So that is just something to take into account. All right. So I hope I convinced you that really understanding the basic fundamental principles of how we visualize helps us to better understand our visualizations and to create better visualizations. And with that, we arrive at a kind of standard set of visualizations. So those are the really basic vises that you have all seen a lot of times and that you've also all created a lot of times. And now, there are actually good reasons why those types of visualizations are so widely used. First of all, they do really fulfill our golden rule number 3, which is less is more. So basically, it's just if your information can be, or if the message you want to send can be achieved with any of these simple visualizations, then why should you go to something more complicated? They are also just really easy to understand. They all use exactly one kind of visual cue to convey the information. So as we've seen, for example, the bar chart uses the length. And so because they are so widely used and because everyone has seen them so often, basically almost anyone can read these charts and understand how to read them. And as a result of that, they also allow us to understand the information fast, because people don't have to spend time understanding how to read your chart. They just can get straight to the information they need. So for those reasons, I would say, whenever you can use those types of charts, go ahead and do it. Right? There's good reasons to use these more simple kinds of visualizations. However, we all know that those are not all the visualizations we use, because sometimes they are just not enough. Sometimes we want to take it a step further. So for example, we want to just show more information, or also we want to maybe show some more complex relationships that we can't show with our simple visualizations. So that is the point where we might want to go from our more standard visualizations to some more complex vises. Now, the good thing is that actually most of the more complex visualizations you can make are based on those standard vises. So they all just take a standard viz and then just take them a step further. I'll show you what I mean. Okay. Let's start with this example. Here we have a map that shows us how our customers are distributed in Germany. So we see, for example, that over here we have quite a lot of customers, and maybe down there, now in Bavaria, we don't have quite as much as we would expect. So there is interesting information in this. Now maybe we want to add more information. Maybe we want to not only know how our customers are distributed, but we also want to know how our sales are distributed. So what can we do? We could, for example, go to this kind of visualization. So that is a bubble chart that shows us, or a bubble map in this case, that shows us how our sales are distributed in Germany. Now let's think how we got from the map on the left to the map on the right. There's actually two things that happened. Well, first we added information, right? We now, in addition to showing how our customers are distributed, we now also show the sales. So we added a layer of information. And how did we do that? By adding an additional visual cue. In this case, the size or the area. So instead of just using those equally sized dots on the map, we now have the bubbles that show us the larger the bubble, the larger the sales. So this is an example of starting from a simple visualization and then just adding a layer of information and a layer of visual encoding to get to a more complex visualization. As a second example, let's look at this chart over here, which shows us the sales broken down by year and by the month in this heat map. Now, this heat map itself is already quite interesting, right? We can easily see, for example, that February 2016 seemed to be our worst month. Also, November 2019 seemed to be good. We also see some interesting trends. So it seems as though our sales are in general a bit higher towards the end of the year than towards the beginning. So that's interesting. But now the only thing is, maybe remember our details guy from earlier. So he's the one who's interested in the numbers and who wants to know all the details. So he might come in and be like, okay, but I want to compare the overall sales 2017 to the overall sales 2018. And that's arguably quite hard to do with this type of visualizations. So what can we do? How can we help our guy? Well, we could do something like this. So what we did here is we kept our heat map, but we extended it by adding those bar charts basically to the corners, to the borders of it. Now, what we did here is basically you take, for example, all the January sales and you add them up throughout all the 4 years, and then you'll end up with the $0.9 million value. Or similarly, you take, for example, all 2016 sales throughout all the months and add them up, and you end up with the 4.8 million bar over here. So now our details guy will be happy because now he can easily see, he can easily compare the overall sales 2017 to 2018, and he can really see the details and the numbers that he's interested in. So again, what happened here is that we started with a simple visualization, the heat map, which just used color to get some information across. And then we just added a layer of information by, in this case, adding a different chart type to our visualizations. And so now again, we have a bit of a more complex visualization, but we also have more information that maybe will satisfy more of a larger audience. Now, an important thing to think about in this case, whenever we go to more complex visualizations, is that we should try to find a balance between the level of complexity and the clarity that we still want. Because with complexity, or with more complex visits, we can, on the one hand, get more information across. And we can also maybe show just some relationships or patterns that we wouldn't have been able to show otherwise. But on the other hand, we always risk losing some of the easy interpretation and some of the fast communication that we can get with more simpler visits. And so the challenge in this case is just to find a good balance between those two. And this is another case where our 3 golden rules can really help us. Because yeah, we can, if we want to find the right balance, we can always go back and think about our 3 golden rules, and then to see what is the message that I want to send and what level of complexity do I need to get this message across. But also, on the other hand, how simple can I make it in order to not lose the clarity? So they can help us guide us through this challenge of finding the right balance. All right, and I'll also leave you to finish up with the 3 golden rules, because like I said, those are the most important ones. If you always stick to those, then you should have no problem. But I would also argue that really knowing or really thinking about how you translate your data into visuals can help you to really make good visualizations. And yeah, that is, I think, the part of data literacy that I wanted to focus on today. Because I think that can really move your visualizations from good to great. Now, if you do want to get in touch with me, I am on Twitter. I also do regularly take part in stuff as Makeover Monday, so I do post visos regularly, so you can also check those out on my Tableau public if you'd like to. And if not, I'm very happy to go to, I think we're going to the breakout rooms next, right?
That's right, Lisa. Thank you very much for your insightful presentation. Looking forward to discuss it in the breakout rooms now. So for anyone who has joined a little bit late, what we're going to do now in the true spirit of a user group is to meet in smaller groups in the so-called breakout rooms, the functionality that Zoom offers to us. So I have sorted people into 3 rooms with 4 to 5 people each. So I will open those rooms now, and yeah, for 15 minutes, feel free to mingle, introduce yourselves, and discuss any data-related things. So yeah, have fun. See you back here in this room with the quiz in 15 minutes.